the AI Kubernetes Show.
Hello, and welcome to the AI Kubernetes Show, coming to you live from KubeCon in Atlanta. My name is William Chia. I'm your host, and I'm very excited to have our very special guest today, who is Oliver Gould, is the CTO and co-founder of Buoyant, the better-looking co-founder, and the creator of Linkerd. Oliver, welcome to the show.
Thanks, William. How you doing?
It's been an excellent day here so far. We've had a lot of great conversations on all topics spanning all elements of AI. I'm curious for yourself, we can have a lot of AI fatigue. Is there anything that has come your way that you felt like this is a take that is not being explored as much? That is, I like talking about this, whereas there's a lot of boring stuff everyone's talking about.
Well, I think as we talk about how AI is getting into production, I mean, everyone's figuring this out right now, right? Where we're seeing kind of like week over week, month over month, these new architectural patterns come out and see new challenges. I was just in a talk with ByteDance and Microsoft where they were talking about the challenges of getting workloads onto GPUs and clusters. And where I think that gets really interesting from Linkerd's point of view, because we kind of sit at the network layer, is that there's a lot in that problem space, as we know from the microservice boom, in fault tolerance, load balancing, retries, timeouts, getting routing, getting traffic to the right place, and where it's going to have a high chance of success. And that problem becomes even more important in the AI inference model world because the cost of failures can be really high where you have to go recompute a lot of work in a lot of places. So I think that Linkerd's load balancing and traffic delivery capabilities are going. The things we've already done here are really well suited for the types of problems that I think we're going to see a lot more of over the next months and years here.
Okay, this is a really interesting viewpoint that I have not heard a lot, where the cost of inference workloads is very, very high. And so having to rerun those is a huge amount of either compute costs if you're running your own model, or it is your API costs out to the providers. So trying to reduce the amount of failures or reruns is this tremendous cost lever for organizations. You were saying one of the ways to do this is within the network layer as you think about routing and load balancing?
That's right. And so if we kind of come to how Linkerd started and what problems we're trying to solve there, it's that it's the same thing we have in a microservice ecosystem, right? There's lots of pieces in a cloud deployment and a Kubernetes deployment. Cloud instances tend to not be super reliable. They don't have uniform performance characteristics. And so when you're trying to serve traffic to a customer, you're trying to get it delivered really quickly with the highest chance of success. And we've got a lot of prior art, decades of prior art in solving those problems in the industry. And what we did in Linkerd, which was somewhat novel, is to make this what I call a layer 5 load balancer. So some people call that layer 7, but operating on the HTTP request layer or the gRPC request layer in that protocol layer, where we can use things like HTTP verbs to understand retriability. We can use status codes to understand things like that. And so the goal is to pull down a lot of the reliability concerns into the infrastructure. And we've done that for HTTP and some of these other protocols. Moving forward, though, we see things like MCP, these new protocols coming out. And those same challenges are going to be present in new ways in these new protocols. And so there's going to be, a lot of the things we already do, I think, can work well there. But then I think there's much more deeper investment we can do in terms of routing, in terms of load balancing, again, all the things that a service mesh is good at today.
This is, as new protocols emerge, certainly MCP didn't exist 12 months ago, is used quite a bit now. And we see folks having a lot of use cases for this. They may be running MCP servers themselves. They may be having workloads that communicate to external MCP servers. They may have MCP communicating between agents. There's a lot of ways that MCP traffic gets into the cluster, but the protocol itself and the challenges there are maybe not as well understood for folks that are platform engineers. What should they know about MCP as a protocol or set of protocols that can be helpful to understand?
Yeah, so MCP is a stateful streaming protocol, which means that things like Multiplexing can get complex. I can't take a bunch of requests from different users and all shove them through one connection, because that connection has state around the conversation that's happening. And that kind of fits the AI use case where they're like one of these models doesn't have multiple thought processes going at once. So there's really just one loop with one conversation happening with each context server here. As we get into load balancing, so like in the classic case, in a HTTP case, we do load balancing, we're generally dealing with short-lived unary requests and responses. So what I mean is I asked you, hey, I want to get this document. And you say, okay, here, as quickly as possible, right? And that's not a really like lengthy transaction. But once you get in these lengthier transactions, you need to start doing different types of stable load balancing techniques. And we probably need a lot more data from the system being fed back into this router to make those decisions actionable and immediate. So I think that there's definitely new functionality that we're going to be building into Linkerd around those lifecycle management of getting deeper into the stream management here. And then on top of that, you have this other set of protocol in the payloads, right? So no longer do we have this just metadata that are there of HTTP request, get, verb, method, method, resource, all that stuff, headers. We have that in addition to a bunch of JSON RPC infrastructure in the request bodies, in the response bodies. I can't go look at a status code to know whether that response was successful or not. I have to go into the body, parse all the JSON, look at the stuff, pull it out. And so there's a lot more, like in the way that we do that for gRPC today, we can do the similar sorts of things with MCP in the future. And that's really where I think, again, that service mesh technology will be really helpful as folks are deploying that for real.
So I'm picking up on several themes here. As you mentioned, there's a lot of prior art where the processes and what's been good in the past, we should take those and apply them to the new technology that comes along. That has worked well. Let's use that prior art. At the same time, this new technology is different in substantive and material ways that change how you need to think about it. In particular, MCP having in the payload elements that are opaque to most of the network tooling that we use today is based off of what's in the header, not inspecting into the payload. So because of the design of how MCP works, there's these set of things that are opaque with the current set of tooling that's around.
That's right, that's exactly right. So the tools we have today don't give you the depth of analysis in that type of like high performance environment, right? And so that's the trade-off, is how do we do deeper analysis without performance trade-offs as we go through this? I think some of the other things we're gonna see here is that the workload types we're talking about are, because there's these different communication patterns in MCP servers, but also with the agent model serving, there's just a different type of provisioning and like multi-tenancy concerns here. So I think the same way that Kubernetes is still relevant to all these technologies, but also is unsuited to a lot of the details that are gonna have to get ironed out. A lot of the service mesh infrastructure that's in there today is in a similar place.
So this is something I definitely would love to dig into. When we say Kubernetes, if we're playing improv word association, I say Kubernetes, you say
microservices,
stateless,
right.
These things go together. But to your point, an MCP interaction or agentic interactions are a contextual loop, more like a long-lived stream. And in a system that's designed to be stateless, how should we be thinking as a software industry about these workloads that want to be stateful, but we're trying to run them in places where they need to scale, and if it goes down, we need to bring it back up, kind of thing?
Yeah, so I think in the MCP case specifically, it kind of depends on the server implementation. Some of them are really simple and don't need all that overhead, and it's better to simplify in there if you can. But where you do, if you assuming you can't constrain your complexity in that place, this actually comes back down, I think, into infrastructure and planning, right? How are we dealing with hotspots and load? How are we dealing with auto provisioning of resources? So especially in the inference case, less the MCP case, where you need more GPUs at peak workflow, peak hours, and you don't want to pay for them at night. You need auto-scaling. Auto-scaling and load balancing are, again, hand-in-hand problems. If you're auto-scaling, you want to select which nodes to send traffic to effectively, or you're coming down, and doing that in a cost-effective way. So like if you're dealing with cross-zone traffic costs and those things, this all adds complexity. So I probably didn't answer the question that you actually asked, but I think that there are going to be a bunch of these kind of fundamental process changes in organizations that have already adopted the microservice pattern of, okay, we have API boundaries between our teams, between our components. We want to be able to iterate these things independently. Totally, that model, that organizational model makes 100% sense in this ecosystem. There's no reason to change that, but the infrastructure itself needs to evolve, and the planning process around it needs to evolve to account for all the things we're learning as we see these things scale out past billion parameters to 100 billion parameters. There's very different needs as we see the scale kind of hit here.
And scale is definitely goes hand in hand with the word AI, as not only people can increase the velocity of the code, organizations can increase the velocity of the development, documentation, testing. All of these AI tooling creates immense scale, and there's more on the way.
Well, in a few ways, right? So one, like you can think of an MCP server as just an HTTP server. All it's doing, it's probably just another endpoint on your existing HTTP API, and it's just doing the same type of backend fan-out requests that your normal API calls would be doing. It's just in a way that's easier for the model to call or for the agent to call, right? You have this better interface to your big API surface area. So as we think about folks using these tools and actually productionizing these tools, what we expect is that much more load is going to be coming, much more web load, just the normal type of web load that we're used to, will be driven by not the web browser, but the agent, or all of these other things that may be driving the workflow.
Well, I like a click back. There was one bit of advice that you mentioned. I want to pull that out and focus on it, which is taking the tools that are available, but scoping them to the case. There's a conversation I had here at the show about a platform engineer that's building MCP servers where there might be one available, but it might bring in 100 tools, and that's too much context bloat. So they're actually building their MCP server to only have access to 3 of the tools to lighten the context bloat. This seems to be an application of what you're espousing, like the technology is there to do many things, but maybe you only need to do these few?
Yeah, and I mean, I think we're figuring out what the right size and shape of MCP servers is for different orgs, right? So there's going to be a lot of rapid evolution here. There's frameworks kind of coming out every day for writing these things or for interacting with them. So yeah, I think finding the tools that have worked well for you in your org today are usually the starting point. And then do we have to go re-platform or re-architect to build these things? Hopefully no. Hopefully these are like incremental additions we can make. Again, because it's not even though what's in the process is wildly different at their GPU and NICs and all these other concerns, the general flow of application level traffic is not all that different.
Well, one thing that's been exciting at Buoyant is we just announced before the show support for MCP in Linkerd. And I would love for you to tell us a little bit about your vision for what this might look like. How are you thinking about MCP support in Linkerd?
So Linkerd has been really optimized around drop in, get running, especially for all the reliability features you need, like load balancing. And again, I keep coming back to load balancing because when we're talking about scale, load balancing is the sharpest tool we have in the shed to improve our reliability, to improve our latency. So with that, I think getting Linkerd's load balancer to have a load balancer mode that's optimized for streams, there's tons of prior art here. It's not like we have to go invent a new load balancing algorithm to do this. We need to go apply them into Linkerd's code base. There's a set of policies that Linkerd already has, so we expect to extend those policies. So there's HTTP route today, there's gRPC route today. We expect to see, today it's called MCP route. That might actually be JSON RPC route, we'll see, but there's a need for additional levels of protocol configuration that extend and work within the existing system. So with the prototypes we have today, I think are a pretty good example of how we see that thing. But there are a couple design things to still siphon out, so we want to be intentional about getting to prod with that. And we want to get some feedback in that loop too. But yeah, I really see this kind of building on our work we've done with the Gateway API for policy definition, for authorization, for we're working today on load balancer configuration via the policy APIs. And so the MCP and JSON RPC feature sets should just extend and integrate natively with those so that you're getting the best in class load balancer we can give you, but it's also configurable. And you're getting great retries and timeouts and observability, but you have control over the cost trade-offs and the performance trade-offs to do that work.
There's existing primitives that we have within Linkerd today that are used and battle tested at immense scale at the largest global companies on the planet, and adding this now protocol support for new protocols as we go, but we're relying on this tooling that is battle tested and works at immense scale.
Yeah, and with those things, I think ultimately we want to be common APIs that are not necessarily Linkerd specific. So in the same way that we've adopted HTTP route and gRPC route, we expect to see similar primitives kind of go into the gateway API eventually. Of course, we'll be part of the we'll be part of that development process there. We're not going to wait for that to land. But yeah, I think that pattern of getting the good primitives in the open standards, getting Linkerd to have great out-of-the-box experiences around them, but also have that second level of control to really customize your experience. Everything we've done for Linkerd in the past, we'll expect to continue doing deeper into this protocol stack.
Nice. Well, I'm curious, stepping back from the world of the industry and what's happening broadly, within your own personal use of AI tooling, what's something that you've been excited about, or you just think has been fun in your own workflow?
Fixing bugs and writing bash that I don't want to write. No, no one wants to write GitHub Actions YAML. No one wants to write Kubernetes YAML. No one wants to write, and it's great for all that no one wants to write stuff, and it is. I actually this past weekend I spent a good amount of time with some of these tools in Copilot and Codex, diagnosing a memory issue that we've seen in Linkerd in the control plane. And it came down to a really narrow race condition between some Go synchronization primitives. And I was able to go to the prompt and just say, hey, I know we have a memory leak that's kind of shaped like this in this part of the code. Help me find it. And that would have taken me probably a week plus, if I had a week plus of time to do it, to really nail down. And it was able to come up with the problem in about 10 minutes or so, right, of getting there. And then within 2 days, I was able to basically, we're still in the process of getting this siphoned out, but I was able to get a prototype of a version of the control plane that uses about half as much memory. And again, I'm not letting it do the design, but I'm letting it do a bunch of the coding and testing work that I don't want to do, especially on a Saturday. But I'm happy to go into the prompt and say, hey, why don't you do a little bit more work for me? So we're seeing this really impact our productivity on the team in terms of code review, in terms of code quality. And I expect that that's a rising tide that will lift all boats in the CNCF ecosystem for sure. Where I think this is good. On our side, I think the pace of feature development will get good. On the production side for folks, though, the velocity of change is going to get a lot higher, and the need for change management, for A/B testing, for load balancing, all the things that we've been talking about are going to be really important as part of that.
This is definitely a theme that's emerged in the conversations that use the humans to do the things that humans are good at, use the robots the things that good robots are good at, and diving through an immense amount of logs, diving through all of this data to try to find where is a memory leak, or even in the code to find where's a memory leak. The AI can be very, very good at searching and then surfacing that for you to then problem solve and do the design.
Especially the reasoning models or the agent models that are able to do greps, and they're able to farm out to these tools that can really dig in, and they can write programs to do the analysis for themselves. And that's stuff that we can do, but it just takes time and someone's priority trade-off. And so it really kind of reduces the bar to, especially prototyping, you're getting to through the hard design decisions quickly so that we can be really intentional about how to move forward.
That's tremendous. Well, Oliver, I've really enjoyed having you on the show. For the folks at home that would like to connect with you online, where can they catch up with you?
Connect with me online. Well, one at Buoyant.io, Linkerd.io. That's the homepage for everything we're doing. But I can also be found on Blue Sky at olix0r.net. So good luck with that.
Oliver, great to have you on the show.
All right, good to see you.
Created by the team at Buoyant.io.